Alright, should be recording. Yes. Not a proper beginning, I suppose. So, anyway, another draft physics video presentation. DraftScience here on YouTube. Alright, anyway, no real agenda, so I think I'll just talk about the basics, the mistakes physics makes, the kind of ones that are overt and almost obvious. They are obvious. You know, the ones they don't fix, like plus and minus being wrongly assigned in the sense that doesn't make any sense to what the actual thing is stating, which is the existence of too many electrons versus too few. And they have that backwards. And it's sort of a significant mistake and, something worth fixing, and they just didn't think it worth fixing. And there's a few of those. So we'll talk about some of that maybe and just see where it goes, frankly. In other news, some commenter, Crimson Ways, left me a little thing about Linux and this MPV thing, so you can just directly load a video and, it works pretty good. So you don't end up with any of the defects of the place it comes from, the ads and whatnot, and the other crap that goes with it. So it does work. My Mint is working pretty good. 20, it loads fast and it's doing everything pretty good. It doesn't crash too often. I mean, only when I do things that I know what causes it, so to speak, in the sense of there's certain times you have to reboot and the system is a little buggy and it's going to crash. Anyway, so when I know more about that, I'll say some more about that. But anyway, I'm liking it so far. Bad beginning, but it's getting better. It doesn't crash, when you reboot. It's not doing that anymore. As long as I don't change anything. So it's always the changes that cause problems. But anyway, it does seem that it's stable enough that if you do the same thing, if I have a routine, I will be able to consistently make a video without having to worry about some problem. A weird thing that it's doing is on a reboot, I have to make sure I change the microphone settings, the output of the volume anyway. It's sending the output to the microphone for whatever dopey reason. And I keep switching it, and it keeps switching it back. And it's really irritating, so I have to find some way to get it to stay permanently where it's supposed to. Because it's just not right. I don't know why it thinks it's right to think that a microphone is a speaker, because that's really dumb. But anyway, so at first MPV thing didn't work because it had screwed up my settings. Anyway, the defaults or whatever. So that was, it's a piece of news. Thank you. Anybody who wants to post any little Linux things, you just have to do this super user thingy and pop in some code and it works and blah, blah, blah. And I like that cut and paste kind of fix a problem. I don't really want to know why it fixes it. I just like to know that you just cut and paste crap and it works. But anyway, so in other news, I have attempted again to communicate with Franklin, who's hard to describe as a human being. He's a bit of a quirky, a little strange, but a lot of nerdy type smart people are strange, so that's okay. He it's my kind of person. He likes to understand the world he's functioning in, likes to fix his own shit and all that kind of crap. So we have a lot in common. He had a bunch of kids, which is something I wouldn't go anywhere near. But anyway, it just never seemed like a good idea to me. Anyway, I keep trying to get, him into a conversation. Now, I suppose maybe I tried it in email and it didn't work, and I've posted comments to him before. I've said things in videos before, And it just seems like there's this huge lag in our conversation, like sometimes months, you know. So it's saying I've typed a comment on his video, and then he responded it 2 days later. Okay, that's not that bad, a day later anyway. It says a day, but it was more like 2. But anyway, and then I responded to him. It's just nothing, but it's just not happening. I think we can have interesting conversations because I think we both are saying what's the evidence really say, and I should be able to persuade him of a few of these things. If I can't persuade, I would say Franklin is a good test, because if I can't persuade him, then I guess people are completely insane and there's just no point in talking anymore. That's what I would almost say, because I think I can make an argument that's the simple arguments. I mean, the obvious argument is, so you got plus and minus wrong. Well, another argument is that there's things called forces and there's things called matter. And we shouldn't be saying the speed of light. We should be saying the speed of force. Now, we can't say that, even though science knows it's true. Like, even though they know that bent space is slow, that is, it moves the speed of light, it doesn't go instantaneous bent space. So somehow bent space has the same limitation as the quantum mechanical virtual photon. It's somehow moving the same speed as the virtual photon, which doesn't really make any sense, right? Like, you're bending space at the same speed that photons are traveling. Come on. I mean, you really, again, if you had a classroom of third graders and they were debating this, they would pretty much say, no, I think they're the same thing. If they're moving the same speed in this context, they might not really understand how to say in this context, but, they would they would make the argument that, now, if they were going to bet their money, right, if you gave them all a bunch of jelly beans and they were going to bet their jelly beans, I think they would bet that whatever's doing the gravity thing, whatever's doing the light thing, whatever's doing the magnetism thing, since they're all moving the same speed, they're all the same thing. And it's just kind of silly to pretend that they're different things, because, they're not. So anyway, we'll move on to just draw some shit. And so we'll start and see where we go. In terms of just explaining that this is all this 2 plus 2 plus 2 physics, and I don't seem to be able to find any chalk of different colors, just in case I want to do that, if I get to the charge subject. So, as I've attempted to point out, and argue and reason with you, there's really no good reason to believe the conventional theory, because gravity is being caused by some fabric bending thing, which it really just comes down to, when they teach it as a convergence. They call it an anti-divergence, and the idea is that as things move away, they get spread out. There's less density of the stuff here than there is here. Okay. And that's the inverse square rule, law. And, so it's not really bent space when they teach it. They teach it as mock gravity, which is really a particle theory. Okay. So even, I mean, that's obvious. That's just a fact. And so people keep talking about this gravity well when they know it's really not a well. Okay, that doesn't work in 3 dimensions. What works in 3 dimensions is a vacuum cleaner idea. This idea that stuff goes somehow, stuff gets consumed going in, okay, to a piece of matter. All right, and we, for the sake of argument, they'll kind of concede that the electron is a stable thing. You're not going to get a half of one. And they've made up this crap about protons having quarks in them, and 3/4 charge and all kinds of other, mush. It's not very good lighting, is it? I thought that other light would improve things, but it really doesn't. So how do I fix that? Simply, I guess I could try the pause feature and try to fix it. So that's what I'll do. Well, yeah, that doesn't transition very well. It doesn't let me know that I unpaused it. I have to actually, well, anyway, it doesn't matter. Not your problem. So I didn't improve it much. So, but you can live with it. Anyway, so, it's a convergence. So anyway, so any material object. So you have these electrons and protons, and we know that they're different. We know that the electron is doing whatever we'll call it, this minus thing, and that the proton is doing whatever we want to call this plus thing. Now, those two colors, well, they're not really different enough, but it'll have to do. I'm saying it'll have to do. I mean, it really shouldn't have to do, but I just don't. Let's see if this is different enough. I think this might be different. Well, we'll see. Anyway, so any little piece of this, right? I mean, the physicists know, you kind of know, right? That an atom is made out of this stuff, and so it's not really a solid thing. It's just made out of pieces of whatever that is versus whatever this nucleus is, and that these are two different elements that are making a composite thing that we'll call an atom. And the atom is a structure. I'd say it has a geometry, and that even when it has a simple geometry, it combines with other atoms to make a geometry. You take 4 hydrogen atoms or something, and you could sort of make a geometry out of it. But anyway, it's a geometry. It's an arrangement. And if the arrangement is imbalanced, that is, you have stuff on this side and you don't have stuff on this side, you can understand that might be called an ion. Or you have extra, 3 on one side and 2 on the other side, that kind of thing, and you get imbalanced atoms. But the point is the atoms aren't really making the gravity, right? We know the atoms have mass, but we know their mass is made out of these electrons and protons, and they're the only things that really has this gravity stuff. So as I have explained, all you're really trying to explain or account for is the fact that what's happening to matter, one of these pieces of matter, is that somehow, okay, there's more energy going in. That is, there's this convergence idea that there's more pressure going in than is coming back out. Okay, somehow the out is less than the stuff that went in. And, it sort of violates this notion of equilibrium, but it also perfectly explains why there's gravity. So the idea is that stuff goes in and somehow the stuff doesn't all come back out. So as I've explained, if you understand a simple principle that, okay, the matter doesn't move for free. So the force, the stuff all moving the speed of light, we'll call the forces, okay, the magnetic field. There's no electric field, but the magnetic field, the charge field, if you want to call it that, and the gravity thing. And what else is there? Well, and then we have the light thing. Well, I've sort of explained. It's just, there's 2 kinds of force, there's 2 kinds of matter, and there's 2 kinds of interaction. So that's really all you need to know. So maybe I'll just do that real quickly. So you have the 2 kinds of charge are just made. So elementally, there's this one's just not gonna do it. We'll use pink. Still not more of a difference. Well, anyway, there's 2 kinds of the force, and then there's 2 kinds of the matter to go with it. Okay, the plus proton and the minus electron. And you have 2 inverse reactions. That is, 2 kinds of ways the force hits the matter. And the 2 ways are the force can hit the matter and move it. Okay, so the little piece of quanta, the wave, the wave, like just one of these waves, whatever that would be called. Yeah, if you're gonna force it to be a wavy verse. If you just can't let it go, all right, and you have to have waves, there has to be a word for one of these waves, okay, so whatever that is, that's the word I want to use, the quanta of the wave. But anyway, so a quanta hits the electron or the proton and it moves it. That is, so there's one version where it hits it, it sticks to it, so to speak. It's occupied moving it, and this thing moves from this position to this position, and then it goes about it's released. And as I pointed out, the transition of moving the matter means it's lost some speed. because the matter doesn't move as fast by getting hit by one little piece of force. Now let's say if I could stack a bunch of forces, like a gamma ray, behind a piece of matter, then you could sort of understand that it would go much faster because it's got more energy pushing it, more little bits of force. So with each bit of force, let's say it can go 10% of the speed of light. Well, you can understand if it has 10 of these things, then it's going almost 100% of the speed of light. That kind of thing. So these can go variable speed depending on how much force is pushing them into the universe of stuff hitting it. And it's when the stuff hits it that it's reflex and all that stuff. But just for the sake of argument, understand that the force is occupied moving the matter. And when the matter ceases to move, it means there's no more forces pushing it anywhere. So it's not using up any force. But you can sort of understand that if it was going the speed of light, the force, you've taken some of its momentum because it didn't get from point A to point B in the same amount of time. And by not doing that, it lost a little bit of momentum. So that explains this scenario. That explains why there's less coming out, all right, a little less coming out than went in to a matter bit. Because essentially every time the matter bit moves, it's taking a little bit of energy out of the universe. It's causing a little bit, a wave, to move slower than it should be moving. It would be moving. And so now the universe has a little less energy in it because you've used it to move a piece of matter from one location to another location. So that's a really simple explanation. And so that's what happens when an electron force hits an electron. It moves it. And when a proton force hits a proton, it moves it. Now, the other reaction to make two, okay, so you have two kinds of force, proton-electron force, two kinds of charge, two kinds of elemental bit, positive and negative, north and south, however you want to look at it. And you just have two interactions. So the one interaction is to move the matter. The other interaction, that is if I have one of these electrons and I hit it with one of these, one of the positive bits of force, it doesn't move it. It doesn't push it. And what happens is the positive bit of force leaves in one of the perpendicular directions. So it goes, left, right, or up and down. It doesn't go forward. It doesn't come out the other end. It changes its direction. It changes the dimension that it's moving in. So it's still moving the speed of light. It doesn't slow down. It doesn't have to move the matter. And it just gets ejected in a different way. So those are the two interactions. Now this is perfectly consistent with what we see in the right-hand rule and in the fact that you can cause a voltage in one direction and cause a magnetic field in another direction. So it's perfectly consistent with what we know happens in the experimental evidence in the sense there's lots of perpendicular transitions in how things move. Yeah, so everything's fitting in here, right? Yeah. All right. So, next. I don't know if this will help any. Get rid of that. And we can probably get rid of everything. Start all over again. So, there's two kinds of force, two kinds of matter, two kinds of interaction. And that fully explains charge. And so that really helps in understanding, say, a magnet. So you could understand that, what's a magnet doing? And so this is the one that sort of gives it all away in the sense that, okay, it's 2 plus 2 plus 2 physics, but it's also understandable as, each one of these things is just a manifestation of the same thing. So for gravity, you have a bunch of this force. I'll do these solid again just to... so you have these two kinds of force, the electron force and the proton force. And they're affecting electrons and protons, right? But they're doing that evenly. That is, just as many electron bits hit a proton as proton bits hits an electron, and vice versa. So you're moving the matter. So you're using, if you hit electrons and protons with a force that was both of these things in even amounts. Okay, so you had even amounts of both of these things in the universe, pretty much. We'll do a squiggly line for the other force and such. So, you're going to move both the electrons and the protons. You're going to, be moving them constantly, one direction, the other direction. In if there was lights all around you, and if you knew the light was pushing you, if you could actually see the push that light did, you can understand that if I put you in an equal amount of light from all directions, you're going to get pushed, but you're just going to keep wobbling. It's not like when two forces balance, it's not like you don't move. It's just that you move 1 second, you move this way, and the next second you move this way, and the next second you move this way, and the next second you move that way. So you're doing a lot of moving. And by doing a lot of moving, electrons and protons are using up the momentum of a lot of force, and that's why there's gravity. So you can understand that when it's a mixed force, okay, and it's just affecting protons and electrons, you have gravity. Okay, that's gravity. Now, magnetism is doing something a little different in the sense that you could argue, the argument I would make is that the electron force, okay, is the north force, and it bounces electrons. So it just reflects them. So they move, but then they go back out again. So they are moving stuff inside the magnet, but they're doing it the same way gravity does it. That's why the magnet still has gravity. And the point is that the stuff ends up reflecting back to the universe in that little tiny unequal amount way. So, but it did move the bits, but it's reflected. So you can sort of understand that all the proton force that hits the south end reflects. Okay, so you understand you're getting all this pink stuff back, all the red stuff, pink, red. See, you really can't see the colors. I have to work on that. Sorry. And all the white stuff is bouncing off the other side. And any pink, okay, that goes into this side, we'll do pink with a dotted line, let's say, gets diverted. Okay, it does that perpendicular thing, so it ends up coming out the pink side. And any, electron force, okay, that comes into this side ends up coming out this side. So you can see that they're just segregating the two forces. So this side becomes very white. So if we're using good colors, you could argue that the mixed field is purple, and that when you segregate it, when you start tearing it apart, you end up, what a magnet's doing, all right, if we could actually see magnetism, we'd see that the magnet is taking purple that comes in, purple light's coming in, and it's sending out red and blue. And that's what it's doing. So it's just a filter. So that's where the energy comes from. The magnet doesn't make any energy. It takes it from the universe, brings the energy in, and the magnet just segregates it and just says, send all the electron blue one way, send all the proton force red the other way. And so it's making a mechanism now that the electrons and protons will see oppositely. So the north end will reflect an electron, push away an electron, and this will push away a proton. And the same is true for the north and south ends of the magnets. Obviously the magnets will flip to become comfortable, compliant, consistent with the field that exists. One end will be pushed away if I put the same magnet next to this one, these two are going to repel, and these two are going to repel. So it's going to make the magnet flip. All right, so you can understand that you have the mixed force, purple, then you have this magnet that segregates the force, and then the other thing you want to talk about are photons, which is a force that we are actually interacting with. So we have little detectors for photons in the sense of our eyes. And what is it detecting? Well, I would argue it's detecting an interaction with electrons. So it's detecting the electron force. It's detecting movement of electrons in atoms, because that's what's causing the electricity. And what we're seeing, okay, is actually electricity. We're seeing electricity between atoms. That's what tells us a photon hit. So what we're really seeing is electrons moving, okay. It's the movement of electrons that triggers for us the notion that light hit us, okay. We don't see light. we see by seeing an electron move from one location to another location in an atom. And that's what triggers for us the existence of a photon. So what's the electron seeing? The electron is seeing force, okay? It's sitting in its universe, okay, being jiggled back and forth because force is hitting it from all directions. But it's also tied to a proton. So it's got a very strong connection to a proton in the sense that all the electron energy that hits the proton goes out this way, and all the proton energy hits the electron goes out this way. So there's no reflections, so there's low pressure between them. So it's tied to that proton. It's bound to it. And the trick is that a photon comes along, and what it's really doing is it's just going to move the electron. Like any other force bit, it's going to stick and move it to a new location. But the trick is, right, so if you're sending extra photons, you have a flashlight, so you have this whole circular, perfect, even amount of light from all directions, and then I show up with a flashlight and I shine extra light from a direction. And if you could feel the pressure, you'd say, okay, from that direction I'm getting a little more pressure. But the key is that just getting pressure doesn't mean anything, in the sense that, you know, what's pressure? How close are the bullets to each other? Now, obviously, if I could make a flashlight that sent waves that were really close to each other, then you'd just be constantly getting hit by these waves. But if I send them periodically, then, if I start spreading them out, okay, you could understand that now they're not going to have quite the same effect. So the photoelectric effect works fine for X-rays and gamma rays and all these very high frequency rays. It's not like something special about blue light. Blue light's just telling you that's the limit. That once you get the bullets a certain distance from each other, you're hitting the electron and he goes to a new position. But the problem is he's in a tension with the proton and with these other electrons. And what he does is it moves back to its previous position before you hit it again. Okay, so if you're throwing red light at it, the electron moves, but it moves back again. And then you move it again, and then you move it back again. Now, if you go faster than that, faster than the rebound speed of the electron, well, then you can move the electron here, and then you hit it again, and it moves here. So that's your extra light. That's your photon. So photons are just the same energy as causing gravity and causing magnetism. It's the special feature is that it's at a frequency. That is, it's a variable frequency. And the things we deal with a lot, radio waves and visible light, and even infrared, the key feature is the fact that it doesn't happen fast enough to kick electrons. And so it can do some subtle other things. So you can have detectors just based on how strong the electron is bound and how fast it rebounds. And so different environments will give you a way of detecting different frequencies. So if you use a different kind of device, you can detect these longer frequencies, because even though it doesn't have enough energy to kick an electron, to kick it free of the atom, it does have enough energy to move the electron, and each electron moving can be understood as putting pressure on other electrons and other electrons and other electrons. And so if you can cause an electrical current, that is, you can consistently move electrons, move this electron to here, and then the electron that was here moves to here, and then the electron here moves to here, then you can cause something called a current, an electrical current, and detect it. And that's what we do. We detect the frequency of the photons, and we convert it into frequency in a wire. The same kind of frequency, the same kind of force between the electrons. We're just converting the energy, but the photons are essentially the same photons. So when we put photons into atoms, the photons essentially stay photons. They're staying waves. They're staying little clumps of momentum, and they're just moving the electrons through the wire. You've provided a medium for them to push electrons. And and the key thing for a conductor is a consistent way of doing that. That is, there has to be a geometry to the atoms that is consistent, so the electrons are all in the same position. So when you hit one electron, hits another electron, hits another, they have to kind of be lined up. And the key fact is when you're sending the light, it's going to hit this one first, right? If I send light at this angle, it'll hit this one first, and then it'll hit at this location, and then it'll hit at this location. So it's pushing the electron as the electron energy is moving. So it's almost like hitting it twice again. You hit this electron, it moves it to a new position. You hit it with another photon at the new position, and then you hit it with another photon at the new position, and that's kind of what polarization is. Polarization is kind of telling you that you have to hit it and hit it and hit it and hit it progressively, and that's going to cause reflections. And it's going to cause electricity, which will cause new photons to be released in the inverse order. First one in, last one out kind of idea, or whatever you want, however you want to say that. First one in, first one out, actually, but whatever, it doesn't matter. It'll reduce, it'll convert the phase, because the process of moving the electron takes time, and that's the phase shift. But anyway, you don't want to get too complicated. You're really moving electrons down, so I mean, see, we could get into the whole refraction thing and all that other stuff, but you could understand that all surfaces are made out of atoms, and all atoms have to have electrons essentially on the outside. There's no such thing as an atom that's a proton on the outside. It just doesn't happen. Even with simple atoms, like I said, you just combine two of them, stick to each other, and they're automatically going to start creating some sort of balance, and eventually you're just not going to be able to have proton on the outside. It's just not a viable material substance. It's not a solid. And so every surface you hit, you're hitting electrons are on the surface. Now there might be fewer or more, right, depending on its charge, but that has more to do with the free type electrons that stick, they're the wannabes. They want to be part of the atom, but they can't quite get there. There's still enough attraction between the protons on the outside of the atom. So there's these electrons that are always on surfaces because there's protons underneath that are still more positive than this negative is negative. This positive is stronger because for the negative to be stronger, it has to be right in the way of the electron. So if I just move the electron out of the way a little bit, then this electron can hang out here weakly, but it'll hang out. So all the surfaces are always covered with electrons. So that's what you're really hitting. When you hit a surface, it's electrons on the outside. So you're hitting electrons, and what you're doing is you're hitting them towards the proton. You can't really avoid it. The protons are in the surface, the electrons are on the outside of the surface. So that's what's causing refraction. That's what's causing the light to bend a little, is the fact that when the electron does move, it's not going to move the same way as the proton, because it's going to be attracted to the protons and it's going to move down a little. And so that's what's causing the angle change, is how big the atoms are will tell you how much the electron's going to move towards the proton. As you apply momentum in this direction, it's going to add some momentum in this direction. And that simply explains refraction. And the same thing is going to happen when you go out. Okay, then the protons are on the inside. Let me just put X's in them. And the electrons are going to be on the outside. And now you're going to do exactly the opposite, in the sense that you're going to push the electron away from the protons. And that's going to cause the same, effect of pushing out in a why would it be the same direction, though? Oh, that's right, because the whole piece of material is a conductor, essentially, and like a conductor of photons. And so when you change this surface, you change this surface. You have to sort of understand, like the atoms inside a glass have to be all arranged so their protons and electrons are in pretty fixed positions, relative to each other. They have to arrange plus minus, plus minus, plus minus, electron, proton, electron, and have a balanced condition. So as soon as you imbalance by hitting an electron, you cause the other electrons to imbalance. And so that's why it comes out the same way. Something like that, anyway. So what else? Might be enough of a video since I haven't gotten this quality of the image quite right yet. So anyway, so they'll all be tied together. The speed of force is a huge. If I could get physics to acknowledge the speed of force rather than the speed of light, it's a huge step in understanding that all of these things have to be made out of the same mechanism. That's why they all move the same speed. You can't have bent space and virtual photons. You have to have real photons. Everybody sort of knows that, right? Virtual photon is kind of a silly notion. And bent space is just a non-answer. It's not a physical thing. It's not physics. It's some other kind of woo. And we know that the only thing that, the thing that we detect is the movement of electrons. And if you understand that the movement of electrons is expensive, that is, it takes energy, the universe has to do work to move electrons, then you can understand why there's a work inequity between how much energy comes into an object and how much energy comes out of the object. That those two things aren't going to be equal because obviously the mechanism moving the matter is the force, and you have to take some of its energy away because you can't move the matter the speed of light. And that simple fact that the force has to actually do the work, and it takes time to move the electrons and protons, and the time it takes to move them is delayed you in getting to your job, so to speak. If you're a piece of force, you've been delayed in getting it to work, and therefore you can't be as productive because you're not going to be as long, because you've lost some time, and losing time is important. So I won't even get into time dilation because that's just another horribly under-evidenced wrong conclusion. But they've got they get all these elemental facts wrong, and those elemental facts are the ones that make it all fit together if you think about it. So once you're thinking that light and gravity are different things, you're already in big trouble. And if you think magnetism is some other magical event, you're in big trouble. So all you have to understand, magnets filter the force. Photons are the force at a frequency. It just means that the force has been caused because matter's moved forward and back. That means that, as I keep saying, is simple. See, this is something that no teacher ever said anything about. But I mean, the idea is if a piece of matter moves in a field of energy, well, it's going to reflect more energy when it's moving towards you, and it's going to reflect a lot less energy when it moves away from you. That's the mechanism that creates photons. But it has to happen between more than one atom. More than one electron has to move because the photon is made out of a composite, from different locations. That's what the polarization is. But anyway, I've been over all that too. There hasn't been any civil or relevant response, and that's unfortunate. And it's hard to find somebody to talk to who knows enough for it to be a useful conversation. So, I'll just keep trying, and we'll see where we go. I've been busy with a whole bunch of proliferate real life stuff, so I don't have as much time to work on these videos. Not that I work on them, but I mean to say what's tomorrow. And nobody's making any videos. I mean, it's just nothing worth responding to from the talking heads anywhere that I know of. So if you have any links to any videos that you think are debunkable or worth the trouble, or that you think are really good physics videos for defending the conventional mush, provide a link and I will see if it's worth the trouble and such. That's all I can do. So I might as well play with my little scene thing one more time since I can. We'll just go back, like that. Just do that all day long. Yeah, I like it. There we go. Good ending. 2 plus 2 physics. That's all there is. 2 plus 2 plus 2. 2 kinds of force, red and blue. 2 kinds of matter, red and blue, plus and minus, north and south. And 2 kinds of interaction. I push you, you deflect me. Those are the 2 interactions for force. Force can either push something or force can be deflected. And with that simple model, you can explain all the physics. That simple model is the physics, frankly. That's why it works, is because it's the right answer. I mean, the odds of me coming up with some 2 + 2 physics that actually worked, that actually could explain magnets and electricity and refraction and all of these different things, you know, photons that are being the same force at a frequency, the absorption of the momentum being gravity, all these pieces fitting together, the odds of it being the wrong answer and having all of those right components, they're pretty small odds. You got to, if you're an intelligent person, you got to admit, you know, those are pretty small odds. How could you answer all of the questions? You know, the fundamental character. How could you describe the fundamental character of all of the elements of the physics mysteries with something so simple and be wrong? It just doesn't seem like that's a possibility, does it? Come on, you have to concede. You don't have to, but you know, you sort of have to have any intellectual honesty. You have to admit it's a hell of a competitor in the theory race. In the race for the right theory, this is a hell of a good competitor. So anyway, we'll end there, and thank you very much. Soon to be, you know, more stuff in videos. Maybe I'll even attempt green screening or something. Probably futile because, you know, blonde hair doesn't do too well, you know, without a black screen, and then, you know, shirts don't do too well. But anyway, I might try. It's such a minor, you know, thing that I don't know if it's worth the trouble. But the thing that is important, I was able to get another camera to work, so I can have 2 cameras. Can't have 3 though. I tried 3. 3 wasn't working too well. It's either 2, I can switch what the second one is, but I mean, I can't get all 3 to work. But anyway, now it's just something for me to play with anyway. So till the next time and such. It should have the right sync and should be proper audio and all that kind of stuff. So some stuff should be fixed. It's getting better, probably.